Hello, what's good leaders? Welcome to Scanso Tutoring YouTube channel. If you are new, welcome. If you are not a subscriber, welcome back. And guys, if you are new, please kindly find it to your heart to click the red button so below and subscribe. Kindly hit the bell for notifications so that you cannot miss my daily uploads. Guys, I upload every day at 4 o'clock p.m. So if you want to catch up, please kindly make sure that you catch up almost every day. Today we're just going to look at September 2025, question number 4. It is as follows: a truck of mass 4,000 kilograms is traveling at the 32 meters per second. We're given the mass, we're given the initial velocity of the truck to the right, the direction, and on the horizontal road at the same time, a car of mass 2000 is traveling at 25 meters per second in the same direction ahead of the truck, is shown in the diagram below, right? Here is the diagram. The two cars are moving to the same direction. We don't need to choose sign convention. If the truck and the car was coming from different opposite directions, we needed to choose the sign convention for the velocities, because the velocity is a vector quantity, not a scalar quantity, right? And it is as follows: the truck collided with the car and the two vehicles stick together. This is so important, guys, to highlight. The two cars stick together after collision, which means now they share the final velocity and move as a unit. Ignore the effects of friction. And then number 4.1, guys, once the question says point 1, you should eat up that question because it's very easy and straightforward. State the principle of conservation of linear momentum in words. We know that it states that the momentum before, sum of momentum before, that means the momentum of the truck and the momentum of the car before collision is exactly equal to the momentum of the truck and the momentum of the car after collision, which means sum of momentum before collision is equal to sum of momentum after collision. Now, the examiner wants you to put this formula in words. Final. Remember, it says sum of momentum before is called sum of momentum after, right? And then you have to put that thing in words. And then if you are putting that thing in words, you should include the system, okay? And the system needs to be isolated for us to have the initial momentum that is equal to the final momentum. Now you're going to go like this: in an isolated system, system, the total linear momentum is conserved. What do we mean by conserved, guys? This name holds the whole entire meaning of the entire statement, right? Which means the momentum before is equal to momentum after, but that is happening only if and only if our system is isolated. What do you mean by isolated system? The system with no external forces, right? The external forces are your fat, which means your friction, your applied, and your tension. If those forces are not present in the system, that means that the system is isolated, right? And then we should move to 4.2. 4.2, calculate the velocity of the truck car system after the collision. Now we have to use what we have stated above, right? And then we are on 4.2, and we said sum of momentum. Okay, or should I calculate it down there, right? We said sum of momentum initial must be equal to sum of momentum final. All right, this means mass velocity of the truck plus mass velocity of the car is equal to mass velocity of the truck plus mass velocity of the car. What is being given to us, right? Let us collect our data. We have got our car. Our car had the initial velocity of 25 meters per second, if I'm not making a mistake. Initial velocity of 25 meters per second, and we've got the mass of the car that was equal to 2000 kilograms. And then we should move to the truck. The truck had the initial velocity of 32,17 meters per second and had the mass of 4,000 kilograms, right? Let us go ahead and calculate, guys. And we said we've got the mass, right? The mass of the A is for the car. Let us put it clear. The A is for the car and the B is for the truck. And then for the mass of the car, that is 2,000 multiplied by the velocity, initial velocity of the car, that is 25, plus the mass of the truck, that was 4,000, plus the initial, or multiply, in fact, sorry guys, multiply by the velocity of the truck, that is 32,17. This is equal to the mass of the car, that is 2,000. Okay, when you come into this side, we know that the both car and the mass, the both car and the truck, they've got the same final velocity. We should put Vf plus the mass of them truck, that is 4,000, and also Vf. We know that they stick together, they've got the same final velocity, right? Which means we can combine everything here using our calculator. That is going to give us 178,680. This is equal to, if you take out the common factor here, you will have this one plus this one, that is going to amount to 6,000, right? And then you divide by 6,000. This side, also this side, we need to divide by 6,000, right? Then you're going to get your final velocity of the entire thing. If you put this one on your calculator, this one comes out of that one. Remember, guys, you're going to have 29,78 meters per second. That means the truck and the car, they've got the final velocity of 29,78 meters per second. Let us go to the other question, guys. It reads as follows: is the collision between the truck and the car elastic or inelastic? You should remember, if we're talking about elastic collision and also the inelastic collision, that on an elastic collision, this is 4.3. On an elastic collision, momentum is conserved. That is, momentum is what? Is conserved. Momentum is conserved. And then the kinetic energy, that means sum of kinetic energy, let's say sum of kinetic energy, it is what? And here we could say sum of momentum initial is called sum of momentum after. The kinetic energy is also, sum of kinetic energy is also conserved, right? And then on an inelastic collision, only the momentum is what? Is conserved. That means the momentum before is called momentum after, but the sum of kinetic energy is what? It is not conserved, which means sum of kinetic energy before is not equal to sum of kinetic energy after, right? This question was so easy and they didn't even ask us to prove, right? But by the look of things, we can see that the kinetic energy is not conserved, right? Which means now our system is what? Is inelastic. I will prove for you guys if I had enough time, but I will do it on the other question. And then the statement goes ahead to say, on an impact, the truck exerts a force of F on the car, right? Will the magnitude of the force that the car exerts on the truck exerts on the impact, the truck exerts a force on F on the car, and now they're asking us about the car exerting a force on the truck on the impact, greater than, less than, or equal to. Definitely sure, guys, this is equal to, right? Name and state the relevant physics law that explains the answer, right? The physics law that's explaining this answer, that is equal to, it is the Newton's third law. That is the Newton's third law, of motion. That says that when object A exerts a force on object B simultaneously exerts a force on object A of equal magnitude but in opposite direction. That means now this truck is going to exert a force on the car, that is on this direction, and also the car is going to exert a force on the truck, that is on this direction, and these two forces are equal in magnitude but opposite in direction, right? I hope you guys, these videos that I'm making are making huge impact and are making you to even study further, and making sure that you pass your exam. Please go ahead to watch my next video that is popping on your screen right now. And guys, go to that exam or break her leg. Sharp, sharp.